So we'll differentiate this implicitly. So I'm going to differentiate this xy function. So this is a product rule because the x is a function and the y is a function. So we end up with 3. Differentiate the x, and then differentiate the y, and that generates our y prime. Differentiating the 2x squared just becomes 4x. Differentiating the y squared, we get 2y, and then since we're differentiating the y is embedded, we need to apply chain rule. And once we've done this, we can leave it like this, and we can calculate our derivative y prime by just substituting and solving for y prime. Here we can probably easily isolate the y prime. So I'm going to factor the y prime out of the terms here. So I end up with, this is 3xy prime. So I'm just going to be left with 3x. I'm going to factor the y prime out of the 2y prime. Group my other terms. So plus 3y minus x equals 0. I'm going to move these terms to the other side and then divide by that coefficient. So y prime times 3x plus 2y, and this becomes positive 4x minus 3y on the right hand side of the equation, and then solving for y prime we get 4x minus 3y all over 3x plus 2y. So there's my derivative. Okay. Now this is an implicit function in that I do need to know the x and y coordinate to be able to calculate the derivative using this implicitly derived function. Here we have the xy embedded in the exponential function. So we're going to differentiate the right hand side. So the derivative of 2 to the xy is 2 to the xy times log 2. And then I'm going to apply the derivative of the inside function. So it becomes 1x times y plus x times the derivative of y is y prime. On the right hand side I get 1 plus y prime. So again, we can isolate the y prime term, so I'm going to group my terms. So this becomes log 2 times 2 to the power xy times x times y prime. So when I factor the y prime out, I end up with log 2 x 2 to the xy. Okay. There's a y prime there, so I'm going to end up with plus. I'm going to move it to this side, so it becomes minus 1. And then that 1 is that 1 there. Maybe I should just highlight a few things so you can see where they're coming from. That y prime becomes that one there. Okay, and these terms here are all these terms here. So on the other side of the equation, we're going to move this y, so we're going to end up with minus y. I'm going to write this as y log 2. Actually, maybe I'll put the coefficient in front, log 2. And then this becomes y 2 to the x y. Okay, and then solving for y prime is equal to 1 minus log 2 y times 2 to the xy in the numerator, and in the denominator it's log 2 times x 2 to the xy minus 1. Okay, so there's my derivative implicitly derived. This one here, again, we have now the y embedded in the sine and the squared. Here we have the y embedded in the cos with the product rule. So differentiating this becomes cosine x squared plus y squared times 2x plus 2y. Now since I'm differentiating y, I need to apply my y prime, okay, my chain rule to generate my y prime. On the right hand side I end up with negative sign xy, and I have to apply product rule here, so it becomes 1 times y plus x times the derivative of y is y prime. Okay, so there it is. I'm going to need to group my y prime terms, so again I'm going to factor out the y prime. That's going to be 2y cosine x squared plus y squared. I'm going to move this term over to the left hand side, so it becomes positive. Positive x sine xy. Okay. And then I'm going to collect my other terms on the right hand side here. Okay, just making sure that I've factored that correctly. Yeah, the y prime factors are there. And then I'm going to end up with negative sine xy times y. So I should put that y. I'm going to put the y on the front here. And then here I'm going to multiply these two terms together. So I get, and then move it to this side. So I get negative 2x cosine of x squared y squared. So now I can divide. So I have y, negative y sine xy minus 2x cosine x squared plus y squared in the numerator, and in the denominator it's going to be 2y cosine x squared plus y squared plus x sine x times y. Okay, so this involved just making sure that you might want to use a few more steps than I did, but keeping track of all your terms, making sure you're applying the chain rule correctly. Okay, there are some chain rule, and in this case there's a product rule as well. Making sure you're able to collect your terms and expand out the brackets correctly. So this is where you may want to use an extra step, because I've expanded and moved things around. You may want to expand to keep track of your terms and then factor in separately.